2 end of unit review. I'm just going to go through the questions and you can go through them at home on your review sheet. Okay, so let's start with number 1. Which statement is true about every parallelogram? 1. All 4 sides are congruent. 2. Interior angles are congruent. 3. 2 pairs of opposite sides are congruent. 4. The diagonals are perpendicular to each other. So it's 2 pairs of opposite sides are congruent. Okay, parallelogram, 2 pairs of opposite sides are parallel is enough to prove. 2 pairs of opposite sides is enough to prove, are congruent is enough to prove that it is a parallelogram. Okay, number 2. A parallelogram must be a rectangle when it's 1. Diagonals are perpendicular. 2. Diagonals are congruent. 3. Opposite sides are parallel. 4. Opposite sides are congruent. So a parallelogram must be a rectangle when the diagonals are congruent. Okay. Number 3, in the diagram, the diagram shows a pair of congruent triangles with angle ADB congruent to angle CDB. So ADB is right here and CDB right here. Okay, and ABD is congruent to CBD right here and right here. Okay, so I just want to point out I'm given angles here. Okay, this says which method could be used to prove triangle congruence, right? I'm given angles here. So I know it's not going to be side, side, side. I know I'm going to have at least 2 angles in my answer. So it's not going to be, oh wait, that has 2 angles. I don't know yet. So it's not going to be side, angle, side, right? Because that has 2 sides. So it's either angle, side, angle, or angle, angle, side. So looking at this, it's angle, side, angle. Okay, that's how I figure it out. I really do that a lot of times. Like if I'm not given a side, right? I'm given 2 angles, I'm not going to be looking at side, 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 or side, angle, side. If I'm given 2 sides, and 1 angle, or I'm given 2 sides, it'll be different. But given 2 angles, I know that it's not gonna, I could just cross those right off the list. Okay, so number 4, if ABCD is a parallelogram, which additional information is sufficient to prove that ABCD is a rectangle? So I'm just gonna make this parallelogram A, B, right, C, D. That's a D. Okay, so AB is congruent to BC. No. AB is parallel to CD. Maybe. But that's true for any parallelogram. So now we have AC is congruent to BD. Those are my diagonals, so that is the case. Okay, AC is perpendicular to BD. The diagonals of a rectangle don't form perpendicular lines. A rhombus and a square do. So let me just erase these so I could move forward, because this is an annotation app, so it won't let me. It'll keep all the annotations in the wrong spots then. Okay, so in the diagram, this is number 5, of rhombus PQR below, the diagonals PR and QS intersect at point T. So PR equals 16 and QS equals 30. Determine this and state the perimeter of PQRS. Now, we know that in a rhombus or any parallelogram, the diagonals bisect each other. So PT, right, is 16 divided by 2, so we have 8, right? The whole thing is 16 to PR, and half of it is 8. I don't get the way. Okay, and QS, right, is 30. So half of 30 is 15. Now, okay, this is a right triangle. I know that because rhombuses, right, their diagonals form perpendicular lines, right? So, um, perpendicular bisectors actually. So we have a right triangle. Now, for right triangles, right, we could use Pythagorean theorem to find, right, a side of a triangle. If we are given two sides, we use Pythagorean theorem, we could find the third side. Okay? So, let's do that. Okay, Pythagorean theorem is a squared plus b squared equals c squared. Now, c is always the hypotenuse. So if I have this triangle, oof, I'm trying to draw. I'm going to use this thing. Okay, I have a triangle. It's a right triangle, right? This is always going to be C. Doesn't matter which this is A or B, but the hypotenuse is always going to be C. So, right, I'll just make a 8 squared plus 5 squared equals C squared. Okay, so, oh, sorry, this is 15 squared right here. Not 5, 15. Let me just... And I'm going to actually change the color to kind of make it easier. Plus 15 squared equals C squared. Okay, 8 squared is 64, right? Plus, and 15 squared. Oops. I'm actually just going to do 15. I'll do the square button. Okay, 15 squared is 225. Okay, 225, and that equals C squared. Now, to find C, well, I could add this even first. So 225 plus 64, okay, plus 64, and that's 289. Okay, so there's lots of different ways you can decide how you want to do that. 289. 289, okay, equals C squared. Now I'm going to start erasing some of this so I have space, right? Or just... Okay, so we had 8 squared plus 15 squared equals C squared. And so 64 plus 225 equaled C squared. Then we had 289. That's a 9. Right, equals C squared. To undo a square, we need to square root both sides. Okay, so these cancel out, the square root cancels out the square, and we need to find the square root of 289. Okay. The square root of 289 equals C. Okay, so I'm going to erase some of this. Is it still there? That's cool, that's cool. I'm just learning how to use this thing. So square root of 289. Second, square root of 289. Okay, so that's 17. So, right, our 289 equals C squared. Square root both sides. And 17 is C. Now, we are looking for the perimeter of this rhombus. A rhombus, all the sides of a rhombus are congruent. That's a property of a rhombus, right? So if this is 17, this is 17, this is 17, and this is 17. To find the perimeter, you could add them all up, okay? Or do 17 times 4, okay? And that's 68. Sorry if you can see that, 68. Let's run a calculator. Okay, so the perimeter is 68. These are not the right spots even. Whatever the units are, 68 units, okay? Perimeter. Okay, and I'm just going to cut that short and make it equal 68. On your paper, you do need to leave your work, right, and write a sentence. But because it's really difficult to do everything with the mouse, right, I wrote a little too big to have everything there. Okay, so let's take a look at number 6. The quadrilateral must be a parallelogram if one pair of sides is parallel and one pair of angles is congruent. One pair of sides is congruent and one pair of angles are congruent. 3, sorry, I read 2 and didn't say it. 3, one pair of sides is both parallel and congruent. 4, the diagonals are congruent. So it must be a parallelogram if you have one pair of sides and the same pair, right? One pair of sides is both parallel and congruent. Okay, diagonals are congruent could actually be a trapezoid, not just a rectangle, and not all parallelograms have congruent diagonals, okay? But all parallelograms have at least one pair of sides that is both parallel and congruent. Okay, so number 7, the quadrilateral ABC with diagonals AC and BD is shown below. Which information is not enough to prove ABCD is a parallelogram? Okay, AB is congruent to CD. AB is parallel to DC. Okay, that can prove it, so it's not this one. Okay, AB is congruent to CD, and BC is congruent to, and BC is congruent to DA. That, right, can prove that it's a parallelogram. So that's not going to work. Let's do the next one. AB is congruent to CD, and BC is parallel to AD. Okay, that is not going to work because they are not the same sides that are parallel and congruent. So we don't know if these sides are parallel and these sides are congruent. It could be a trapezoid, right? That's not enough to prove it. Over here, we have opposite sides of parallel, so that is enough to prove it. Okay, let's take a look at number 8. The diagram below, AC and BD intersect at E. Which information is always sufficient enough to prove triangle ABC and CDE are congruent? Sorry, triangle ABC is congruent to triangle CDB. So, AB is parallel to CD. That does leave us with a lot of information. But those are all angles that they're going to leave us with, right? Angle, 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 and that's not enough to prove it, okay? We could find the alternate interior angles congruent, but it's not enough to show that the triangles are congruent. So let's take a look at the next one, right? AB is congruent to CD, okay? BE is congruent to DE. All right, so in this case, we have a side-side angle, right? So that's not enough. Okay, so let's get rid of this. E is the midpoint of AC, okay? E is the midpoint of AC. So right now, we just have an angle side. That is not enough. How about number 4, BD and AC bisect each other? Okay, well, then we know we have some congruent segments here. Okay, we know that AE is congruent to EC. And we also know that BE is congruent to ED. And we also know vertical angles are congruent. So this is enough to prove that the triangles are congruent by side, right? Side, angle in the middle, side. Okay, awesome. So let's take a look at number 9. All right, an accompanying diagram of rectangle ABCD, angle BAC equals 3x plus 4, and angle ACD equals x plus 28. What is angle CAD? Okay, so we have BAC, which is 3x. Let me see if I can make this smaller. So we have 3x plus 4. Oy, that's not easy to see. Okay, that's this angle. And we have angle ACD, x plus 18. What is angle CAD? So we want to find this angle. Okay, so we know that in a rectangle, right, the full angle, all of the full angles are 90 degrees. Okay, so we know that this plus this equals 90, this plus this equals 90. We also know, because the lines are parallel, right, that these are alternate interior angles and they're congruent. So we have 3x plus 4 equals x plus 28. That should say 28, not 18. Okay. So let's subtract x from both sides. We get 2x plus 4 equals 28. Okay, I'm going to minus 4 from both sides. And we get 2x equals 24. Okay, x equals 12. We divide by 2 on both sides, right? X equals 12. 2, divide by 2, and x equals 12. Okay, we found x. So now we need to find, well, what is this angle equal to, right? We're looking for CAB, finding out what it's equal to so we can use that to help us find the complementary angle. So x equal 12. Let's plug this in. Okay, now you could plug it in here, you could plug it in here. I just plug it in here. 12 plus 28. It's easier than doing 3 times 12 plus 4. So 12 plus 28, right, is 40. Or you could have done 3 times 12, 36 plus 4. So this angle here is 40. Okay, that would mean that this angle here, right, is 55. I feel like that's got to be wrong. Why would they set it up like that? It says 12. All right. So CAD equals 55. Let's take a look at 10. In the accompanying diagram, CA is perpendicular to AB. Okay, CA perpendicular to AB, and we have that right angle there. ED is perpendicular to DF. We have a right angle here. ED is parallel to AB. Okay, so this is parallel. CE, right, is congruent to BF. AB is congruent to ED. Okay, and CAB equals FED equals 90. So this is also angles that are congruent. So over here we have side, right? Side, and we have, this is not the full side. Okay, so there's a couple of different ways. Okay, this says which statement would not prove, which statement would not be used to prove triangle ABC is congruent to triangle DEF. Okay, so in this case, we know nothing about DF and AC, okay, as far as if they are congruent. So I'm going to say side, side, side is what can't be used, okay? So over here, I'm already seeing a side, right? And I know because these two are parallel that we have these angles that are congruent. So I already see angle, side angle, but that's not there. Also, I know that CE, right, and FB are congruent. So if I add EB to CE, I get CB. And if I add the same amount to FB, right, then I get FE, and those are congruent because I added the same amount, the addition postulate, right? So it's side angle side, right, can be an answer, right? Angle, angle, side can be an answer. Angle, angle, and the full side can be an answer. Same addition postulate, right? HL, hypotenuse leg, we know that's 90 degrees. That can be an answer. So the only one is side, side, side. And notice I really kind of figured that out before I went through all of them, right? I saw there that I don't have a third side given, right? And there is nothing I can do to prove that those are congruent. So that's the one that could not be used to prove it. Side, side, side. Okay. So the next one, in the diagram below, triangle ABC and triangle XYZ, right? In the diagram below of triangle ABC and triangle XYZ, a sequence of rigid motion maps angle A onto angle X, angle C onto angle Z, and AC onto XZ. Determine and state whether BC and YZ, or sorry, BC is congruent to YZ, and explain why. So, A and X map onto each other, okay? And C and Z map onto each other. And we're told that AC maps onto XZ, okay? So, okay, and now we need to determine if BC and YZ are congruent, okay? Well, I know trying to see if I can write on this where my writing thing is. Ooh, smiley face stamp. I love that. I can't get off of it. Okay. Oh, that's a stamp. Okay. I would prefer. Nope. I was trying to find a way to just write on here, but actually I found a way. Of course, I can just use actual text. I'm like, okay. So, we have, right, an angle, a side, and an angle, right? So we know that triangle ABC and is congruent to triangle XYZ, right, by the angle, side, angle congruence theorem. Okay, and right, we therefore, right, right, BC is congruent to YZ, right? Line segment BC is congruent to YZ because corresponding sides of congruent triangles are congruent. Okay? You can't just say that they're congruent. You have to explain, okay, why. Okay? So I'm actually going to take that out now because okay. Number 12, okay, in the diagram below of parallelogram ABCD, diagonal BED and EF are drawn. EF is perpendicular to DFC, so this is perpendicular. Okay, DAB is 111, and the measurement of angle DBC is 39. What is the measure of DEF? Okay, well, to find out what this angle is here, before we get to DEF, we know that this is, right, alternate interior angles. We also know that this is supplementary. So 111 plus 39 plus something plus something, we'll call it x, equals 180, right? Supplementary angles add up to 180. All right, so I'm actually just going to do 180. Minus 39 minus 111 to find out what the angle is. And I got 30 from that. Okay, so